Okay. All right. Let's get started. Happy Friday. Happy week 5 Friday. We are after today. We are halfway done with the quarter, at least the lecture part, and then I guess you have finals 11th week. So maybe the halfway point is until next week. I guess I don't know. We have a midterm exam next week. And so I've posted this document, old 102A winter midterm, and let me go over this a little bit. So in here, I list off, I guess, lectures that I will draw material from, and so you can take a look at that. One thing that I will not be putting on the midterm exam will be stuff from Arvest or importing, exporting, Lubridate, that kind of stuff. So that one lecture is not going to be on the midterm, but you can expect other stuff to be there. Now, don't ask these questions on CampusWire because I won't answer them. If you ask, do we need to know this topic? If you ask that on CampusWire, I'm not going to answer it, and your classmates also do not know if those topics will be on the exam or not. Basically, this is the information I'm putting on here, and that's what you can expect. These are kind of some older some questions. I don't. Obviously, the questions that appear on the exam itself will be different, and I don't want to hear your complaints that what I put on the practice questions were significantly easier or whatever than what actually appeared on the exam or something. Obviously, they're going to be different. It's not my intention to make the actual exam problems like any more difficult or less difficult than what's being presented here, but obviously they will be different. A lot of the theme of what you will see is, there's some code. Some of the code will not be very well written. So for example, this first problem, I have a function. It's a function of y. Inside this function, we do y plus 1, and we store it as y. And then we have 2 times x. And, it's referencing x. X is not defined inside the function. So what's it going to do when it tries to do this, and what is the value that it's going to return? And so inside this function, outside the function, the global environment, we have 3 assigned to x, and the name y is bound to the value 5. We call function of x, or f on 3, that gets put in here. What's it going to return? And the answer is, well, it'll do this, and then it'll do 2 times x. It doesn't find x inside the function, so it checks the global environment. It's going to return 2 times 6, or 2 times 3. It's return 6, and that's going to be that. Okay, so it'll kind of test your ability. The hope is to test your ability to read code, even code that is not super great. Here's some stuff on like, okay, what is this going to return, and the type of this will be a list because single square brackets on a list is always a list, and what will that do? So anyway, as you go through kind of the practice midterm questions, I encourage you to try out and see, write down what your answers are, what you think they are, and then you can check to see if you got it right or wrong by all you have to do is you just literally type in, or even you can copy and paste it, but probably type it in and see what it outputs, right? And you can kind of check your answers that way. And a lot of questions are kind of set up this way where it's going to be kind of testing your ability to read and see what R is going to do. And that's that. That's going to be an important aspect, important skill to learn. I will include this one regular expression cheat sheet, so you should kind of familiarize yourself with it, so you can see what parts of regular expressions, make sure you understand at least what's on this cheat sheet. So this one sheet will be included on the as part of the midterm exam. I will also allow you to bring a sheet of notes, one sheet of notes, okay? And I'll make sure I put some details on Canvas as well. So students are allowed to have one basically letter size 8.5 by 11 sheet of notes. It can be handwritten, it can be typed. My only requirement is that you make it yourself. So I don't want, like, if you want to study together with a friend and you want to talk about what to include on your cheat sheet or your sheet of notes, that's fine. But I don't want one person to make the sheet and print off multiple copies or something like that. So you are required to just make your own sheet. It can be typed, it can be handwritten, and I will ask you to turn it in with the exam. Okay, so that's that. That is one sheet of notes. I guess I don't know. Are there questions about that? Yeah.
One side or both sides?
Both sides. Okay. I'll make it clear. All right. And the intention is for it to be kind of like a reference, not to be like I mean, I've seen students do this. I don't think it's an effective use of the cheat sheet, but like they've like shrunk down the slides from like multiple lectures into like these, they've tried to fit like 50 slides onto a single page, and I don't think that's a good way to make use of the space. But what you do with your thing is up to you. And again, I will ask you to submit your sheet when you do it. The exam is pen and paper. It'll be in this classroom. I will send out a seating chart the day before. Okay, so it's a little bit weird, and I know some of you have like your own, like, this is the seat that I've always sat in ever since the first day of class. I'm gonna just kind of assign seats randomly. Okay, so I literally use the computer and I say random, and it creates a random number for every student, and then I use that to kind of assign you to a seat. And so that will be that. So that's the midterm exam. I don't know, any other questions about that? One thing about the exam is, well, okay, if you are sick, don't come to the exam. And then also, if something happens and you're not going to be able to make it to the exam or something, let me know ahead of time, okay? Don't, if you take the exam and then you say, I was going through this at the time and that's why I performed poorly, I can't do anything after the fact, all right? If something happens and you feel like you're not going to be able to take the exam, let me know ahead of time. I try to be accommodating, if you give me a good reason. But I can't do it after the fact. Even if I'm, very sympathetic about your situation, I can't just say, oh, I'll let you retake the exam or something. There is one change to R that happened, and one of your classmates pointed this out. So this is the change log. This is like, you can, an R project, this is kind of like every new release, they say, all right, these are new features and these are changes and stuff like that. In R 4.2.0, one of the major things is that calling if with a condition or while with a condition of length greater than 1 now gives an error rather than a warning. So it used to be, so I think in one of these problems I have a function. Okay, so here's a function, and in an older version of R, so D is this vector of, what's the length of D? Length 3, right? 1, 2, and 4. Okay, the null doesn't count as part of the length of D. And then, and we put it in function G, and inside function G, it says if the argument A is divisible by 2, then do this or that. Okay. Older versions of R would have just looked at the first value and said 1 divisible by 2 is false, and then it computes this. This quantity is a logical vector, goes false, true, true. It would have looked at that first value of false, and it would have gone with the false, and it would have also returned a warning. Now, if you give the if statement a logical vector of length more than 1, it returns an error. So that would return an error. And so, I will be mindful of that when I write my problems, so we won't have but I guess as of now, if I were to include a problem like this, I would have to accept both kind of answers, the warning versus the error. And then, in future lectures, I will make sure to point out that it does return an error, and if your computer doesn't return an error, you need to update your version of R so that it's the latest version and things like that, okay? So that is something that has changed. I think perhaps your lecture notes still have kind of the warning rather than the error as you review your lecture slides, but that's something to take note of. Anything else? So I've posted homework 4, and I think now is a good time to kind of go back to the very first lecture, where I talk about a few things. Okay, and here's this slide that says no pain, no gain, and I want to kind of you've had a few homework assignments now, and I just want to kind of emphasize that I believe the real learning for this class happens outside of the lecture when you're doing the homework, okay? We meet together and I talk for 50 minutes, and we do this a few times a week, or you watch a video of me talking, and you have the slides and whatnot. But the real learning of like how you develop your skills and stuff happens when you're doing the homework. And so my hope is that the homeworks have been challenging and but doable, and that you're learning from them. And so again, the skills that I want you to develop and think about intentionally as you're doing the homework are your ability to read and write code, your ability to debug and kind of pinpoint, like, when you encounter errors, can you figure out what is producing those errors, right? And you guys are asking questions on Campus Wire about like, hey, here's the error I'm encountering, and I see a lot of people responding, which is great, because that's showing me that these students who are recognizing like, what does this error mean and how to solve it, that's a good sign. And I hope the people who are asking about the errors are learning from that, of trying to identify and figure out what problems are, okay? Homework 4 with, you're using R6 object-oriented programming to kind of simulate the movement of Monopoly pieces and stuff like that. You're going to have to kind of think about, how do we decompose this problem into something smaller? And so that's going to be a problem-solving thing. And again, start small, test it out after each thing, make sure it's kind of working the way you want. Reading documentation is also important. Again, think of this as like a coding 2 class, like a writing 2 class, but instead of writing essays, you're writing code. And then, and again, the intention is, as you do it, the fact that if you feel challenged, that's a good sign. It means you're being kind of stretched, you're being pushed, and that's my hope for you as you work through the homework assignments, as you kind of work through this, is that you are learning and you are, I guess, getting better. That's what we want. So I guess that's my encouragement as you approach these homework assignments, that kind of grow and stuff. All right, let's take a look at today's topic, which covers Ggplot. All right, some of you are already very familiar with Ggplot. I don't have some of you taken Stats 15 with me? All right, so if you took Stats 15, I covered Ggplot quite extensively in that course. Some of you might have seen Ggplot in Stats 20. You might have seen Ggplot in some of your other courses. Others of you, about Ggplot, you tried to use Ggplot, but you're only kind of just vaguely familiar with it. So this is kind of just a brief introductory lecture to Ggplot. I encourage you to use this textbook, the R Graphics Cookbook, okay, which I've linked to in the lecture, and it's a great resource as far as there's this table of contents is huge as far as like, okay, here's like making a scatter plot, and here's how you start by making a basic scatter plot, and how do you group your points, and how do you do this and that. All of these things are in there. So a lot of the things you want to do will show up in the table of contents. And then as you work through Ggplot, another aspect is you just go to Google, right? I mean, you don't have to type in Google. You can just type straight in your search bar now, and then you type, you say, I want to, what is it that we want to do? Okay, change Ggplot. Map counting. I guess these are past searches I've done. Let's say you wanted to do like log scale. Okay, Stack Overflow is pretty great. All of these other things. The other thing is just do Ggplot reference. Okay, and then function reference on Ggplot will also have a lot of stuff here. Okay. So that's going to be things. I've got a bunch of slides here. We're not going to get through all of them, but I just want to kind of talk a little bit about the philosophy and some of the ideas of Ggplot and the idea of data visualization, and then I'll leave you to the rest. Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter B. B as in bear. B as in bear is your first view quiz answer. So Ggplot is part of the tidyverse, and part of going along with that is we expect our data to be in tidy format, meaning each row is an observation, each column is a variable. The GG in Ggplot stands for Grammar of Graphics, which is kind of this philosophical idea about what does a data visualization do, developed by Leland Wilkinson, and I'm a big fan. I'm a big fan of Ggplot. That is to say, I still use base graphics quite a bit. I think base graphics are great, but I also really like Ggplot as well, especially if I'm going to do something a little bit more complicated and whatnot. When we create a data visualization, the big idea here is that we are mapping properties of the data or values in our data to properties, visual properties of our graphic. Okay? So if we are making a scatter plot, we might have a data set where we've got different people, each person is an observation, and we might have different variables about these people. Okay? One of those variables could be the person's height, another variable could be the person's weight, another variable could be the person's gender, or their hair color, their race or ethnicity, or just whatever aspect about this person that we've decided to record. And what we are going to do is we are going to map values from the data to visual properties of in our graphic. And so visual properties might be, if we're thinking of points to put on a scatter plot, visual properties are like where on the x-axis, horizontally, where does this go? Vertically, where does this point go? What is the color of the point? What is the shape of the point? What's the size of the point? Things like that, okay? If we are not mapping or tying a visual aspect to something that comes from our data, this is not a data visualization. It's just a picture, okay? So here's a very simple data set. I've got 6 individuals represented in this data set. We have some people, their heights, their weights. In this data set, we have their gender and their hair color. And we are going to make a scatter plot based off of this, okay? And so in the scatter plot, I'm going to map the person's height to the x-axis, the person's weight to the y-axis, their gender to the color of the point, their hair color to the shape of the point. And this is the graphic here, okay? And so if we look at this individual, this first individual, 62 inches tall, 120 pounds, female, brown hair, we can see those that is visualized right here. This point right here is in the horizontal X position is at 62. Vertical position for weight is at 120. We can see the color is this reddish color, which corresponds to female. This shape is a square, which corresponds to hair color brown. Okay, and that is what we see in this thing. Okay, and if you think the amazing thing, or what data graphic does, is it allows us to use parts of our brain that are able to process visual information, and it communicates the data to us using those aspects of the brain. And so if I gave you this graphic and I said recreate the data, okay, you could do it, right? So you could look at these 6 dots and you could recreate all of the values in the data exactly, right? So I don't think anybody memorized that table, but let's look at this dot. What is this person's height? Okay, we'd say, okay, around 72 inches. What is this person's weight? It's a little above here, so we're going to say around 190 pounds. Okay, this person's hair color, we see it's a triangle, so it corresponds to blonde hair. This person's gender, we see it's this blue color, we say it's male. Okay, and we could do that for every single point, and we can recreate this data. So when we created the data graphic, we went from the data table to make this visualization, and then I can give you the visualization, and I could say recreate the data, and you would be able to do it. All right, and that's what the purpose of the data visualization is. I'm trying to transfer the information in this table to you, okay? And I could transfer it this way. I could transfer it using text, and you would be able to receive it. But I can also transfer the same information with this graphic, okay? And you would be able to recreate this table if you needed to with this graphic. Now, the thing about the graphic is it utilizes different parts of our brain. So we see dots, and we can identify, our brains are really good at like looking at dots and identifying patterns. And we can say, oh, there's kind of a straightish line pattern here, right? And if I said, try to guess which dot has the largest positive residual, if we kind of fit height and weight, you'd be able to identify it, right? Which dot seems to be, like if we fit a trend line, even though I haven't drawn a line, if you imagine drawing a trend line, which dot do you think would have the highest positive residual? Probably this one, right? Okay, so we can look at this scatter plot and we go, okay, there would be a trend line around here. This one would have the highest positive residual, right? And that's because our brains are able to kind of look at dots and identify these kinds of patterns. If I gave you the same assignment and I said, look at these values and identify the point with the highest positive residual, this is much, much, much harder to do, right? I mean, you would have to like really study and think about these dots, and really probably the only way you would be able to do it and say like, oh, okay, the point located at 65,160, that's going to be the one with the highest positive residual. That's like way harder to do if it's just presented as numbers, okay? And so the visualization, it's the same information, but this utilizes our brain's natural ability to kind of see dots versus like our ability to translate these things. It's actually really remarkable that we can even communicate information and we can receive it, right? Like I'm talking right now and it's amazing. Like my tongue and my voice box is like vibrating the air, and then your ears receive these air vibrations, and you go, oh, he's speaking, and I understand what he's saying, right? And then it's also amazing that you see this little squiggle of a shape here, all right? And your brain goes, oh, that's the number 6, and it represents like this quantity, right? And then here's another squiggle, and that represents, this quantity too. But then when they're arranged this way, that represents 62, and like, but that uses a different part of our brain that says, okay, we're going from squiggles to numeric concepts and stuff like that. And we get information this way. But, if I said, hey, what's the point with the largest positive residual? Really hard to identify, okay? Over here, I say, hey, what's the point with the largest positive residual? I mean, the fact that you even know what a residual is like a separate thing, but he said, like, okay, fit a trend line, which dot is like highest above the trend line? We go, oh yeah, it's gonna be this one, okay? And that's kind of the power of data visualizations. But the also important thing is, like, all of the information in this table is also being communicated, right? And if I took away, say, if we did not include this the numbers along here, we would lose a lot of information, okay? We would not be able to recreate our table. If we didn't label the vertical axis, we would lose that information. I don't know if, like, in high school you had like a science class and you had to like draw graphs or something, or maybe middle school, and then the teacher was like, oh, you didn't label your x-axis properly, minus 10 points, and you're like, no. But we also recognize how important it is, because that was our life, right? Like, you lose 10 points on a thing and it feels like, no, great. But if I hid, right, if I didn't include this legend here that said circle corresponds to black hair and triangle corresponds to blonde hair, or square, like, we would not be able to recreate our data as well. Okay, so let's talk about some terminology, because these are the aspects here. All right, so the data, that's what we want to visualize. It's we're assuming it's tidy data, so each row is an observation, each column is a variable. The geomes are the geometric objects that we are going to use to represent our data. So our geometric objects could be like points, okay, graphed here, but we can also create bars, we can create lines, things like that. The geometric objects have visual aesthetics, okay, so visual properties of the geometric objects, such as, where do we put this point, horizontally or vertically? Or what is the color of this point? What is the shape of this point? Those are aesthetic attributes. And the mappings tie basically the columns or the variables to the aesthetic attributes. Okay, we're mapping data values to attributes. How do we go from the data to the visual property? That's controlled by a scale. All right, so we can say, if the value is 60, does it go in the middle? Does it go all the way far on the left? Does it go on the right side of the graphic? That's controlled by the scale, okay? If the value is 100, where does it go? Or if the gender is female, what color should it be? Those are controlled by the scales. And then the guides, just as important, is once you create this graphic, how does the person who is viewing the graphic go back to the data space? That's you need to provide guides, which are basically just tick marks or legends that inform the user. Okay. So in our example, we have a scale that is determined automatically by Ggplot, and the guides are also automatically produced by Ggplot. And that's one of the nice things about Ggplot, is that it does a lot of this hard work for us automatically. It looks at our data and it says, this is your biggest point and this is your smallest point, and so I'm going to determine where to put the endpoints of your box. This is your biggest point and smallest point. This is where I'm going to determine, what colors to use, things like that. And then, and if it does that, it also creates legends or tick marks and stuff for us. So that's one of the nice things, is that Ggplot does a lot of this creation of scales and guides, or handling of scales and guides, for us automatically. We also have control over changing or tweaking any of those things if we want to, but it does a lot of that automatically. Okay, let me give you your second view quiz answer, which is the letter E. E as in elephant. E as in elephant. Okay, so here we mapped height to X, weight to Y, gender to the color of the point, and hair color to the shape of the point. And sorry, someone decides to call me. This is what our scatter plot looks like, okay? In our data set, there were two genders represented, and so we have two colors of points represented. If we had another data set with more genders represented, we would have more colors represented. In our data set, we have 3 hair colors represented, black, blonde, and brown. And again, if we had more hair colors represented in the data set, we would have more shapes. But we have right now 3 shapes, circle, triangle, square, and we have 2 colors, at least in this small data set of 6 people. And this is kind of the range of heights that we've observed in this data set and the range of weights that we've observed in this particular data set. What would happen here if I swapped this, swapped the 2 categorical variables? We are going to represent the hair color with the color of the dot and gender with the shape of the dot, okay? Well, again, in our data set, we have 3 hair colors, so now I have 3 different colored dots, okay? And in our data set, we have 2 genders represented, and so I have 2 different shapes of points here, okay? This graphic and this graphic present the exact same information. If I said, recreate your data with this graphic, you could do it. If I say, recreate the data with this graphic, you could also do it, okay? Now, they look different, even though it's the same thing, and that's one thing that we note is that our eyes generally notice the color of a dot before they notice the shape of the dot, okay? So here we kind of recognize there's 3 colors, red, green, and blue right away. Over here we see, this, I don't know, reddish and tealish color over here. And probably over here we recognize the shapes after we recognize the color of the dots. And that's just something that our brains kind of notice first. And so, in that, with regard to that, if there is a, quote, more important categorical variable that you want to represent, probably tie that to the color. And then if there's another, secondary categorical variable that you want to represent, you put that with the shape or something, okay? And so that's what we have going on in these things. Can I do something like this? Can I take the categorical variable hair color and map it to the y-axis? Is that possible? What will happen if I do that? Can I take a numeric variable like the weight and can I tie it to the color of the dot? What would happen if I do that? Yeah. Yeah, so we can do stuff like this. This feels a little bit odd to us, but it can be done. So here in our data set, we had 3 hair colors represented. And so people with black hair appear in this position vertically. Okay, people with blonde hair appear in this position vertically. People with brown hair appear in this position vertically. Okay, the weight is numeric. And so what Ggplot does is it uses a color gradient. And it says dots with dark color, something close to black, will represent people with weights of around 120. Dots with light blue represent kind of our highest value for weight, something around 190. And if I said recreate your data, you would be able to do it. Your numbers for weight probably won't be super accurate because it's kind of hard. And we might say, okay, this is the darkest point at around 120, but then like what value do I use here? It's a little bit hard, right? What value do I use here? That's kind of hard to do. This will probably be our highest value at 190. But we would get at least ballpark figure-ish for the for our data set. And again, it's the same information, that's being presented here. It's the same information being presented here. It's just we've mapped these numeric and categorical variables, these different variables, to just different aesthetic attributes. And it might feel like we're doing different things, but at an abstract level, all of these data visualizations, all of these graphics are doing the same thing. So representing a numeric value with where we put it vertically at an abstract level is the same thing as representing that numeric value with some shade of color, right? Dark shade, light shade. We're just taking a value and we're tying it to some visual aspect, okay? And that visual aspect could be the vertical or horizontal position. It could be the color of the point. It could be the shape of the point or something like that, okay? Some aesthetic attributes will only work with categorical variables, such as the shape. So the shape has to be kind of categorical in that, you know, there's just like a limited number of shapes, right? You can have triangles, circles, squares, or something like that. I mean, you could tie it to a numeric attribute if there's only like a certain number of numeric attributes, right? If it's only possible to get 1, 2, or 3, you could choose to represent them with a shape, but you'd effectively be treating it like a categorical variable. Other things could work with both categorical or numeric variables, such as the X position or Y position. We saw, the categorical variable of hair color being tied to Y position. We saw color being tied to a categorical variable, but color can also be tied to a numeric variable, and things like that. And so far we've been doing with scatter plots, but similarly, like for a bar graph, generally you would put like bars at different horizontal positions, and those horizontal positions are probably going to be categorical, and you can also kind of rearrange those bars and stuff like that. So yeah, that's what we are doing with a data visualization, is we are tying values in the data to aesthetic attributes, and that's kind of the key concept that you have to kind of keep in mind. And if you understand that, then really all of the other stuff with Ggplot is just, okay, what is the visual attribute that I want to kind of mess around with, and how do I kind of control doing something like that? This is just a little section on Ggplot versus base graphics, just to kind of say, like, if you're trying to do something, Ggplot makes your life easier. I don't know if you've ever tried to create a legend in base graphics. Have you ever tried to do that? Was it fun? No, right? So here's some code like to create a legend in base graphics, and like creating this legend for like the color of the dots correspond to genders, and the shape of the dots correspond to the hair color. Like, that is a pain to do in base graphics, and the fact that Ggplot does it automatically for us is a huge time saver, and so I'm very, very grateful for Ggplot. It is possible to do stuff like this in base graphics, but again, I think Ggplot makes our life so much easier by kind of just automatically creating these graphics legends for us and things like that. Let's take a look at building up one of our graphics here. So again, here we're going to start off with this simple data frame where I've 6 individuals and stuff. I can create a Ggplot here, and I don't know if you've had this experience where you create Ggplot and then like nothing appears, okay? And that's because I haven't given it any geometric objects to produce. So all I've said is, here's the data frame that we're going to look at. I want to tie height to the x-axis. I want to tie weight to the y-axis. Ggplot looks at the data and says, oh, the range of values I see for height go, from around 62 to 72. So it automatically kind of determines the edges of the window. The values it sees for weight, have a certain range, so it automatically kind of determines the edges for the window there, and it kind of produces a plot, but it has no geometric objects to produce. So what I need to do is I need to say draw points, okay? So I do ggplot, height is x, weight it gets mapped to y, and now we add geom points, geometric objects, and it does this thing, okay? And so now we have a data visualization, and if I give this to you and I say recreate our data, well, you would only be able to recreate the height and weight attributes, okay, or height and weight variables, because those are the only variables that got represented in this data graphic. We have no information about any of the individuals' genders. We have no information about any of the individuals' hair colors or things like that, okay? One thing that you might see is you might see plots stored as objects. And so this previous command, where I did ggplot plus geom_point, I could take the ggplot stored as object p, and I could do p plus geom_point, and it would be equivalent. And here with p plus geom_point, I could add another aesthetic attribute, and I could say map gender to color, okay? And so, so this is what we have, and again, in our small data set, there were 2 genders represented, and so now we have 2 colors plotted on here. And if I said recreate the data, you would now be able to write down height and weight and gender here. And that's what we have, okay? We can also change settings of our graphics. Settings are not aesthetic mappings. Settings will change the way our graphic looks, but they are not associated with any of the values in our data. So here, I'm going to set color to blue, size equal to 10. This is not an aesthetic mapping because I am not using this function AES. So back here, I said AES color equals gender. That says look at the gender variable and associate it with the color of the point. Here, it says just set the color to blue. We don't care what the data says. Just set the size to 10. And so this changes the way our graphic looks. It set the color of the points to blue. It set the size of the points to 10. But the color and the size of the points do not communicate anything about the data to us, okay? We have no, if I said recreate as much information as you can about the data, in this case, we can only create the height and weight variables, okay? Because no information is communicated by the color of the point, and no information is communicated by the size of the point. Now, we might want to do this for our just kind of preferences, and we might prefer the way the graphic looks, by increasing the size, because something like this, we might say, oh, these dots look really small and I want them bigger, so you want to change the size of the dots. That's fine. But again, it's important to note that this does not communicate anything about the data. These are not aesthetic mappings. These are just settings here. Okay. We could modify how the values get represented. Okay. So Ggplot automatically looked at the data and said, oh, you know what? The smallest value I saw was 62, so that's going to go on the left edge. The largest value I saw was 72, that's going to go on the right edge. Now, you might say, I know a little bit more about this, and I think the left edge should be over here, and the right edge should be this value, and you can kind of modify some of these things. So here I can say, I want to change the x limits, okay? And so I can do scale x continuous. I think there's actually just a quick shortcut because it's such a common thing. You can just do xlim, and that will change some of the stuff. And again, if you're not sure about what is the command I use, you go to the R Graphics cookbook, and a lot of the aspects are going to be listed off in terms of some of the things in the table of contents, and then the other resource is just you go online and you just do a search, ggplot, how do I do this, and you'll probably find your answer. But here we're changing the x scale, and now we have 60 on the left and 100 on the right. You can also change, make it a log scale if you're dealing with values that are, some values are much bigger than other values and stuff like that. If you wanted to change the colors that get used, you can set the colors manually. And so here I'm saying, I want to use the colors orange and green rather than that reddish salmon color and that bluish teal color. You can do that as well. There are themes. It's hard to see on the projector, but on the PDF there's like this light gray background. And if you prefer just to kind of have a black and white thing, you can use theme black and white. There's theme line draw, which will draw the tick marks, in a darker line, stuff like that. We have that. Okay. I'm going to skip over a bunch of these geometries. Probably the most useful ones are the point, line, and bar or column geometry. And I actually have to update some of these slides. And I'm just going to kind of skip over a lot of these things. You can kind of review them on your own time as you try to make plots and stuff. But I do want to highlight one aspect is sometimes you will have data, and the data are in different data frames, and you can combine them into a single plot. You're not restricted to just having all of your objects come from one single data frame. So here I have one data frame called function data, and this function I'm just doing cosine of x, and I'm going to do a geom line. And so I draw a line kind of representing cosine of x from 0 to 6 radians, so just a little bit short of 2 pi, and so we get the cosine here. And that data is stored in this data frame function underscore data. Here is just another data frame, and this data frame is called df underscore points. And so to add this, I'm going to do geom point. I have my aesthetic mapping of x goes to x and y goes to y, and here I specify the data for these points come from a different data frame, df underscore points. And so now I can combine the points coming from one data frame, the line coming from a different data frame. So I'm able to kind of combine values from different data sets into a single Ggplot. Okay. Here is another data frame. This one is called df underscore segments, and this is if I wanted to draw segments on my plot. Okay, and so segments, you can do geom segments and geom segments, and basically to plot a segment you need a starting x and y coordinate and an ending x and y coordinate. A lot like the arrows that you drew on chutes and ladders. You needed a starting xy and an ending xy, and that's what I have here. I got 8 segments. My starting xy is here and here. My ending xy is over here and here. And if I wanted to add this, I take my current plot and I'm going to add segments. And I say, this is x1 and y, or x and y, and x end and y end, and the data are coming from this data frame, df underscore segments, and I'm plotting that. So I kind of want to just highlight the ability to kind of draw different things from different data frames into a single plot there. Okay, let me give you your last view quiz answer. Last view quiz answer today is the letter D. D as in dog. D as in dog is your third view quiz answer. And that will be it for today. Have a great weekend. We will see you on Monday. And good luck as you study and prepare for the midterm exams.